All right, we want to find basically the reactions and the tension in the cord for this system. Okay. Now, what it says here at the start is it says that it's got a 25 kilogram bar with at the center of gravity. So let's talk a little bit about that. We'll start drawing this free body diagram. Okay. And what that's saying is that we can assume we can basically take all those infinite number of particle forces and condense them all right down to a single force at a single location, just like we did when we did the uh, equivalent systems. And basically say equivalently, it would be like if all of the force was acted right at the center at point G, which I'm going to call 25 kilograms times 9.8. Okay, so we've got that load right there. Okay, now let's go ahead and include our tension in the cable right here. This is a 15-degree angle. This is a 30-degree angle. I'm not sure if we need that, but we've got that in there. Okay. I have a roller at A, so it's free to move horizontally, but can't move vertically, so I have to have a reaction there. Same thing at C, right? This thing can slide up and down along the line of action um, of the rod, but what I can't have is any motion vertically or perpendicularly to it. So I've got C acting perpendicular to rod like that, which is going to come in handy with my moment equation, which we'll get to in a second. Okay, so again, I've got the mass at the center. You've got a roller, so you've got A straight up, you've got tension going at that angle, and then C is going to be perpendicular, because again, it could slide the length of the rod, it just can't move perpendicularly to the rod. So I have to have a force perpendicular to restrict that motion. So let's go ahead and sum the forces in the x direction here. Okay, so I have T cosine 15, and again, what I'm doing here is I'm going to call my x and y axes just my typical horizontal and vertical, right? So I'm going to have T cosine of 15, right, in the x, and then, okay, so this one's perpendicular. This has to be a 30-degree angle from the vertical like that. If it's perpendicular, the rod's at 30 degree from horizontal, perpendicular to that is going to be 30 degrees from vertical. So that will then become negative because it's to the left, and that'll be C sine 30. Those are my only forces in the x direction. Do the same thing with the y direction. This one, however, has A going up. Okay, T is going a little bit up too, so that'll be T sine of 15. I have my force downward, the weight, which is 245. I get that from 25 times 9.8. And then I've got, again, C, but this time cosine 30, and it's acting straight up. Equals 0. Now let's sum the moments. I'm going to sum the moments about A. Why? Because I've got the unknown A there. I also have the unknown T there. Okay. What I'm going to do here is I'm going to take the moments about that. So A and T go away. Now I've got my 245. I got the weight. That's a vertical force. So I need the horizontal distance. That horizontal distance will be 0.5 times the cosine of 30. That is the horizontal distance times that vertical force, which of course is 245. This guy creates a negative moment about point A clockwise moment, so I put the negative in there. So I get that horizontal distance times that vertical force. And I only have a vertical force, so I only worry about that. Now, recognize that C is perpendicular to the rod already. So I can just take that 0.7 distance times that C. That is the moment around that because it's already perpendicular. It's a counterclockwise rotation. So it's going to be 0.7 C equals 0. And again, I can do that because C is perpendicular to that distance 0.7. So I don't need to worry. I could break it up into horizontal and vertical, but that's a lot of extra sines and cosines of 30 that aren't necessary when I know that C is perpendicular to that 0.7. So from that, I can find that C equals 152 newtons. I can plug that into the top equation, find T to be 78.5 newtons, plug C and T into the middle equation, and find A equals 93.4 newtons. Okay, so that time I got all the directions correct, so they're all positive. Again, just draw that free body diagram. Look at how motion is restricted, draw any reactions based on that. Then just go ahead and sum the forces in the x, sum the forces in the y, set them equal to 0. And then sum the moments about the point with the most unknowns going through it, set that equal to 0, and then just go through and solve those three equations for those three unknowns.